Hey everyone, ready for a deep dive? Today we're taking a trip into the world of high-frequency trading. Yeah, that world where millions of messages are flying around every single second. Decisions happen like that.
You might be thinking, what does Wall Street have to do with my AI research? But stick with us. The way a high-performance financial exchange is built. Well, it's got some seriously cool lessons for anyone building complex systems, especially data-driven ones.
And we've got some awesome insider info to help us along. Notes, study guides, even a presentation transcript from, get this, the folks over at Jane Street, all about how they designed a system to handle the crazy volume and speed of, well, Wall Street.
What's wild is that they do all of this with, get this, a single server. Yeah, you heard that right.
Wait, one server for a whole financial exchange? Seriously?
Yeah.
I'm already picturing the reactions from the NASDAQ Q-Tech folks when that idea was first floated. I bet they were like, hold on, one server.
They were definitely skeptical, that's for sure. But Jane Street's design, it's all about simplicity and raw speed, two things that are just as crucial in AI as they are in finance.
Okay, now I'm starting to see the connection. Faster processing, more efficient data handling, that's music to any AI researcher's ears. So spill the beans. How does this single server actually work?
At the core of everything is the limit order book. Think of it as this dynamic record of all the buy and sell orders in the market. It's constantly updating and it's organized so that buyers with the highest bids, the ones who want to pay the most, and sellers with the lowest offers, the ones selling for the least, they're always matched up first. Everyone gets the best price.
So it's like, what? A giant constantly updating auction with the system automatically connecting the most eager buyers and sellers.
You got it. And to keep everything running smoothly, the exchange relies on four main types of messages. First, you have new orders coming in. Then you've got cancels, which remove orders from the book. And of course, cancel replaces these modify orders that are already there. And finally, executions. This is when a match happens and a trade actually goes through.
Sounds pretty familiar, huh? Kind of like the event streams we're dealing with in AI all the time. That constant flow of data that needs to be processed and acted upon in real time.
You're catching on quickly. And just like in AI, making sure that everyone's got the same information at the same time is critical for fairness and transparency.
So how do they handle that in this crazy high-speed world? They got some kind of like super fast messenger pigeon service or something.
Not quite. They use something called multicast. It's a networking technique that lets them send messages to everyone at the same time, simultaneously.
So it's like a broadcast system where everyone gets the news at the exact same moment.
That's it. But there's a catch. Multicast relies on UDP, and UDP is known for, well, being a bit flaky. It's kind of like sending a message through a crowded room. Sometimes it just gets lost in the noise.
Uh-oh, that's not good, especially in a financial market where every millisecond counts. So how do they deal with that?
They came up with a pretty ingenious solution: retransmitter servers. These servers act like a safety net. They store all the messages, and if any get dropped, boom, they resend them right away.
So it's like having a backup communication channel that kicks in if the main one goes down. Clever way to ensure data integrity.
Right, this idea of redundant systems and rock-solid communication, it's something every AI researcher can learn from, especially when you're building systems that are distributed.
Okay, so let's talk about keeping this server, this, what do they call it, this monster server, from going completely haywire. How do they make sure this thing is stable, reliable, and doesn't just lose all the data if something goes wrong?
This is where the magic of state machine replication comes in. It's a concept where every part of the system processes the same sequence of transactions, and they do it in a totally deterministic way.
Deterministic, huh? Does that mean you could predict exactly what the system is going to do at any given moment?
You got it. It's like a perfectly choreographed dance. Every step is planned out in advance, and everyone ends up exactly where they're supposed to be.
And I bet that makes testing and debugging a whole lot easier, right?
Absolutely. They have a guy there, Pete, who can literally replay weeks of market data through the system to test out new stuff or track down bugs. It's like having a time machine for your code.
Now that's something I wish I had in my AI work. Determinism and reproducibility are, like, the holy grail in AI research. This approach could be huge for building more reliable and transparent AI systems.
It's definitely got potential. All right, let's move on to another challenge that's common to both financial exchanges and AI, shall we? Parallelism.
Parallelism, that's all about doing multiple things at once to speed things up, right?
Yeah.
Sounds like a no-brainer for a high-performance system.
Well, on the surface, yes, but it's not always that simple. While parallelism can boost performance at the individual, symbol level, it can make things tricky when you're trying to manage risk across the entire market.
Ah, I see. Because you need to see the whole picture to make smart decisions. And that gets a lot harder when you're splitting things up.
Exactly. Now, here's an interesting insight from Jane Street's experience. They found that a big chunk of their performance gains came from optimizing how they access memory. Being able to grab multiple pieces of data at the same time, that's where the real magic happened.
So it's like having multiple checkout lines at the grocery store. The bottleneck just disappears.
Exactly. It's a reminder that sometimes the biggest performance gains come from focusing on the little things, like how you handle data.
Okay, so we've got all these messages zipping around. How do they keep everything in order and avoid, total chaos? It's like directing traffic in a city during rush hour.
They've got this brilliant locking mechanism that keeps things running smoothly. Think of it like a super sophisticated traffic control system for data.
Okay, break it down for me. How does this data traffic control actually work?
Every message gets tagged with a specific topic. It's like assigning it to a particular lane on the highway. And within each topic, messages are processed one after the other in a strict sequence. So everything happens in the right order.
So it's like a perfectly organized queue. Everyone knows their place.
You got it. And to prevent, any fender benders, they have a system where client ports propose transactions and sequence numbers. And if there's a conflict, they just back off and try again, gracefully. This keeps the whole system consistent.
That's a pretty slick way to handle things, especially when you've got so many things happening at once. It sounds like they've thought of everything.
They've certainly put a lot of effort into it. And these ideas of concurrency control and conflict resolution, they're just as relevant in distributed AI systems as they are in financial exchanges.
Wow. This has been a really cool look inside a high-performance financial exchange. I'm already seeing some connections to the world of AI, the speed, the reliability, all very impressive.
And this is just the beginning. We'll dive even deeper into their architecture in the next segment. We'll talk about how you can adapt some of these ideas to your own AI and ML projects. Don't go anywhere.
Welcome back, everyone. We're diving deeper into the world of high-performance financial exchanges. And last time, well, I was pretty blown away by that whole one-server approach.
It is pretty remarkable when you think about the sheer amount of data and the speed they're dealing with. But it's not just about raw power. It's about optimization, optimizing at every level.
Okay, now you've got my attention. What kind of optimizations are we talking about? Always looking for ways to make my AI models run faster and smoother.
Well, one area they really excel in is memory management. Remember, in high-frequency trading, every microsecond matters. They've designed their system to minimize the time it takes to fetch data from memory.
Yeah, that makes sense. Memory access can be a real bottleneck in AI, too. If you're constantly waiting for data, well, your models are going to slow to a crawl.
Exactly. So what they do is they pre-allocate huge chunks of memory. It's like creating these pools of ready-to-go resources. Think of it like setting up dedicated shelves in a library for the books you use all the time.
So no more searching through the stacks, huh? Everything's right there, ready to go.
Right, and they take it even further by minimizing data copying. Instead of moving data around all the time, they use pointers and references to access it directly.
Ah, so it's less about physically moving the books and more about having like a detailed map that tells you where each one is. Smart.
Exactly. This laser focus on memory efficiency is a big reason why they can achieve those crazy single-digit microsecond latencies for their internal transactions.
Wow, that is fast. I can definitely see how that kind of optimization would be huge in AI, especially for real-time stuff like robotics or autonomous driving.
For sure. Now let's switch gears a bit and talk about another cool part of their design, their use of functional programming languages, specifically OCaml.
Oh, come on. Gotta be honest, not super familiar with that one. What's the advantage there?
Well, OCaml, and functional programming in general, encourages a style of coding that really emphasizes immutability and determinism.
Okay, hold up a sec. What exactly do those terms mean? Break it down for us non-functional programmers out there.
Sure, immutability basically means that once you create a piece of data, it can't be changed. Think of it like writing something in ink, it's permanent.
Interesting. And how does that help in a high-performance system?
Well, when you have tons of operations happening all at once at lightning speed, immutability really helps to prevent those nasty surprises. If you know data can't be changed randomly, you can be way more confident that your calculations and decisions are, on solid ground.
So it's all about making the system more predictable and less likely to have those weird bugs. Makes sense, especially in a financial exchange where a small error could cost a lot of money.
Exactly. And that leads us to determinism. In a deterministic system, the same inputs always lead to the same outputs. It's like a recipe, follow the steps, and you always get the same cake.
I like that analogy. And I'm guessing determinism is just as important in AI as it is in finance, right?
Absolutely. It makes your models more reliable and easier to debug because you can easily retrace your steps and figure out why a model made a certain prediction.
Okay, so functional programming sounds pretty great, but I've heard it can be a bit slower than other approaches.
Mhm.
Is that an issue here?
It can be, yes, but the architects of this exchange have found some clever ways to reduce that overhead. They're actually achieving performance that's comparable to, lower level languages like C++.
So they've managed to get the best of both worlds, the elegance and safety of functional programming without sacrificing speed.
Exactly. And that's a great lesson for AI researchers who are often facing those same trade-offs. Finding that sweet spot between performance, reliability, and maintainability, that's the key.
Okay, now let's talk about fairness. In a financial exchange, everyone needs equal access to information. No insider trading allowed.
Absolutely. Achieving that level of fairness when you're dealing with millions of messages per second, that's a real challenge.
You need to make sure no one is getting a sneak peek at the data, right?
Right. And that's where multicast comes in again. By broadcasting updates to everyone at the same time, it creates a level playing field. It's like a live news feed that everyone gets at the exact same moment.
Makes sense. But even with multicast, couldn't there still be tiny little differences? What if someone has a slightly faster internet connection?
You're right. Those small differences can matter in high-frequency trading. That's why they've paid close attention to network design and configuration.
So it's not just about the software, it's about the hardware and infrastructure too.
You got it. They use high-quality network cards, switches, cables, everything. They've carefully optimized how their network is set up to minimize latency and ensure that data flows smoothly. It's like building a highway with no traffic jams or potholes.
Wow, sounds like they've really thought of everything. It's impressive how they've managed to create such a fair and level playing field in such a high-stakes environment.
They had to. The integrity of the whole market depends on the fairness and reliability of the exchange. It's like the foundation of a house. If it's not level and sturdy, the whole thing is at risk.
And that's a great analogy for AI systems as well. As AI becomes more integrated into our lives, we need to be just as rigorous about ensuring fairness, transparency, and accountability.
Well said. Now, before we wrap up this part of our deep dive, let's touch on another critical aspect of their design: security.
Of course, with all that money flying around, they must have some serious defenses in place.
You're not wrong. They use a multi-layered approach to security. It all starts with strict access controls and authentication protocols.
So only authorized users can even get in the door.
Right. And once they're in, their activity is constantly monitored and logged. It's like having security cameras and motion sensors everywhere.
It's pretty secure. What else are they doing to protect the system?
They use encryption to protect data, both when it's being transmitted and when it's stored. This makes it much harder for attackers to snoop on sensitive information, like putting all the valuables in a vault.
And I bet they've got some serious intrusion detection systems running too.
Oh, yeah. They have a robust system that's always looking for any suspicious activity, and it can raise the alarm if anything fishy is going on, like having a team of guards on patrol.
Wow, it really does sound like they've thought of everything.
They have to. In the world of finance, the stakes are incredibly high. A security breach could be disastrous.
That's definitely a sobering thought.
Yeah.
And it's a reminder that as we build these powerful AI systems, security has to be a top priority.
Absolutely. We need to learn from the best practices in cybersecurity and cryptography and design our AI systems with security in mind from the very beginning.
Well, this has been another fascinating look into the world of high-performance financial exchanges. I'm constantly amazed by the ingenuity and the attention to detail that goes into building these systems.
Me too. And there's still more to explore. In our final segment, we'll delve into how they handle risk, manage those complex order types, and how they keep their system evolving to keep pace with the ever-changing world of finance.
Can't wait. I'm already seeing how these ideas could be applied to some of the challenges we're facing in AI. All right, welcome back to the final part of our deep dive into, the world of high-performance financial exchanges. We've learned so much already. It's crazy, that one server philosophy.
Yeah.
Still mind-blowing. And their obsession with speed and security, definitely taking notes.
It has been quite a journey, hasn't it? But remember, a truly great system isn't just about cool technology. It's about adaptability, that ability to, evolve and improve.
Right, makes sense. The
Hmm.
world of finance, it's
Yeah.
constantly changing, right? A system that can't keep up, well, it's going to get left behind. It's got to be like a shark, always moving forward.
Exactly. And the folks who designed this exchange, they knew that from the start. They built their system with change in mind. They used modularity and abstraction to create a flexible and adaptable architecture.
Okay, got to stop you right there for a sec. Modularity, abstraction, there's some pretty fancy words. Can you break them down for us regular folks?
Sure thing. Modularity means breaking down a big, complex system into smaller, self-contained pieces. Like, think of it like Legos. You can swap out or upgrade those pieces without messing up the rest of the structure.
Okay, I'm with you. So if one part breaks, you don't have to rebuild the entire thing, right?
Right.
What about abstraction?
Abstraction, that's all about hiding the complexity, focusing on what really matters, the core functionality. Like when you drive a car, you don't need to know how the engine works to get where you're going, right?
Ah, so modularity and abstraction working together. They make the system flexible and easy to understand.
You got it. This lets them try out new tech, new algorithms, you name it. They can constantly tweak and improve the system without starting from scratch each time.
That's a great lesson for anyone building anything complex, especially in AI, right? Things are changing so fast, you got to be able to adapt without everything falling apart.
Couldn't agree more. All right, let's shift gears for a minute and talk about another crucial piece of any financial exchange: risk management.
Right, even in a perfect system, things can go wrong. And when you're dealing with millions of dollars, even tiny mistakes can have huge consequences.
No doubt. That's why they've got this multi-pronged approach to risk management. They start with strict risk limits for everyone involved.
It's kind of like setting a budget, right? Helps you
Yeah.
stay financially responsible.
Perfect analogy. These limits prevent any one trader from taking on too much risk. It helps protect the whole market from, going off the rails.
Makes sense. But what about those unexpected events, market crashes, that sort of thing? How do they handle those?
They've got these really sophisticated systems that monitor the market in real time, 24/7, looking for anything unusual, anything that could be dangerous. It's like having a team of financial detectives always on the lookout for fraud or manipulation.
So they're not just sitting back waiting for things to go wrong. They're proactively looking for trouble.
Exactly. And if they spot something fishy, they can step in fast, they can halt trading or adjust those risk limits we talked about.
So it's not just about preventing bad things. It's about having a plan. If they do happen,
Yeah.
that's good advice no matter what you're doing, especially with powerful tech like AI.
Absolutely. AI is getting more complex, more autonomous all the time, right? The chances of something unexpected happening, they're only going up. We need to be ready.
This deep dive has been so eye-opening, seriously. We've learned about their design, their focus on speed and reliability, their commitment to fairness, security. It's incredible.
And that constant drive to get better, right? Never settling.
It's amazing, isn't it? A system built for Wall Street, for all that financial craziness, has so many lessons for the future of AI.
It goes to show that inspiration can come from anywhere. And by studying these systems, we can really understand what it takes to build truly awesome technology.
Couldn't agree more. So everyone listening, keep learning, keep digging deep, and keep making those connections. That's where the magic happens.